A shopper pushing a cart through a store moves 400 meters down one aisle, then makes a 90-degree turn and moves 15 meters. He then makes another 90-degree turn and moves another 20 meters. All right. So this problem is pretty interesting because there's many scenarios, and I'm going to give you. But I'm going to presume that I'm going to give a reference point as when he says to move one aisle, we don't generally know which direction that up, down, nor left, right, who knows. But we're going to do this, folks. We're going to just call it traditionally right, left, and when it says 90 degrees, I guess we can call it up or down. It doesn't really matter. So initially, a shopper moves 40 meters, and then it's going to make a 90-degree turn. So I'm going to pick my direction here. It could be 90 degrees here. Or it could be 90 degrees here. So, and it travels 15 meters. And then he makes another 90 degrees turns and travels 20 meters. So, the thing with this is there's two directions that this chopper can take. It can either take this direction or this direction. So this could be either 20 meters on this side or 20 meters on that side. And notice it's the same thing here. It could either be 20 meters on this side and 20 meters on this side. And if you're perceptive, we can kind of cheat a bit and say that whatever the end displacement is, it's just going to be the opposite sign of the vector. So the horizontal component is going to be practically more or less the same, but the vertical component is just going to have the opposite sign. So whatever the opposite sign of the displacement is. So, move 15 meters. Oh my god, hold on. So 40 meters and then makes 50 meters, and then he makes a turn and moves 20 meters. Oh, okay, so I was right. Okay, so something like this. So the question is asking how far is the shopper away from its original position? But let's look at the hint. Normally I don't look at the hints, but I'm going to make an exception for this problem. Notice that we did not specify whether the shopper turned right or left. Explain how many answers are possible for parts A and B and given the possible answers. So notice that I've drawn all the possible scenarios, folks. So you could either turn this direction, either of these directions, or either of these other opposite directions. And realistically, folks, this vector right here, it said an aisle, so it didn't specify which direction. So let's rotate this left. So it could, I guess, maybe be this vector right here. That's also a possibility. Notice that you have either these components all over the place. In fact, let's find them. But let me, and then we have the other components. Let me see. We can rotate this, flip vertically. There we go. It could be in this direction. So ultimately, let's just get the magnitude values out of the way. So for this scenario, folks, there are 1, 2, 3, 4 possibilities on this scenario, on this particular vector. So let's find that vector. That's why this problem is a little fun, because I can, because you know. You would think that because there's many answers, I would be lazy. But no, I'm going to just take the opportunity and just have fun with this, and I can actually explore, and that would be very helpful video to do these kinds of problems. So anyways, let's find the horizontal and the vertical component. And I'm going to give myself a little space. So the horizontal component is going to be 40 meters plus or minus 12 meters. Notice that I set straight out plus or minus 20. And the sine part is going to be plus or minus 15 meters. So I'm going to write that as the answer, actually. In fact, let's do that. Let's write 40. So this is a possibility. This is going to be 40 meters. In fact, so B could be 40. So B could be 60, 15, B could be 60 and negative 15. That's a possibility. The other vector could be 20, positive 15. B is going to be 20, negative 15. So right off the bat, folks, these are the possible vectors that you could get. Now, you would think that this is all of them, but it's not, folks. Notice that we didn't specify. It just says that the thing moves into an aisle. So this is going to be a possibility of vector for part A. It can move towards the left side of the component. So let's write that. So let's establish if it starts to move left, and let's. Now this is another possible vector. You travel 20 meters, you go 15 meters up or down, and you travel. What's that? Oh no, this is 40 meters. Yeah, 40 meters, 40 minus. So that's going to be negative 40 plus 20, and 40, 20. So so this is going to be 20 meters. So this is all meters here. And this is going to be negative 40 as the vector. And this is going to be a positive that it's going to add, and this is going to be a minus. So the first component here for x, and notice that we're going to have 4 possibilities in this scenario. And the 4th possibility would be negative 60 meters on both sides, positive 15, minus 15 meters. So we can already read that off the bat, or you can have negative 40 plus a 20, which is going to be negative 20 meters. That's the displacement. Positive 15, negative 20, and negative 15. There we go. So left and right has already been established. You have 8 possibilities. You can already tell that you're going to have 16 total. All right, let's establish these other possibilities for the vector. So notice that it's going to be the exact same thing, but we're going to go downward. So we're going to go down the axis. So we're going to go down. Oh my God, this is going to be confusing. Negative 20 meters. And you're going to go down a little further. No, 40 meters. Negative 40 minus a 20, which would be negative 60 meters. And then you're going to take the difference of that, which you're going to go down negative 40 and then up 20. So that's going to be negative 20 meters, I believe, if I didn't make a mistake. And the horizontal component, it's just going to be 15 minus 15, 15 minus 15. This is another possible scenario that this could be, depending how you draw these. And last but not least, folks, let's do one more vector. So it's the horizontal component. It's going to be plus or minus 15. So 15 meters minus 15 meters. The vertical component is going to be up 40, so that's going to be 60 meters. Or 40 minus a 20 would be a 20 meter difference. So 60 meters. So this is going to be negative 15 meters and positive 15 meters. This is going to be 60 meters or a 20 meter. All right, folks, let's pull the solution manual on this one. So this is number 14 here. So if we assume the floor is level, take the x-axis in the direction of the first displacement, that's just going to be 4 possibilities: up, down, left, right. So it could either be 40 meters or 20 meters. Wait, what is this? I can't look at this. Okay. If one turn is to right or left, this plane adds up to that. Oh my God, I can't even read this. just two answers are possible. I don't think that's correct, folks. You know, if you travel to the right side, you're going to travel 40 meters or 20 meters, depending on where you start and end the location. And what is the final result of the vector? This is kind of weird. I have a hard time reading this. 20 meters, maybe. So it's going to be 40 plus 20, and which is going to be 60, 40 minus 20. So these are the two possibilities. And it could either be up or down. So it's going to be plus or minus 15 meters. So that's four possibilities. And if you flip, and that's presuming you travel, you know, to the right side. If you travel to the left side, those are another four possibilities. And if you travel up or down, that's another four possibilities. So it's really just 16 possibilities total, with 16 combination of the angles. So they might need to, I don't know if they're going to need to fix this problem. I mean, you guys can let me know what you think, but I already drew all out for you guys. If the solution manual is not going to go all the way, neither will I. So realistically, folks, you could answer however you guys like. So anyways,